Hey, second graders, it's Mrs. Seals back for our next science lab. So, for the past couple weeks, we've been talking about what we call natural resources, which are things that are made by the earth that we use. Remember, natural means it comes from the earth, it's not made by people, and a resource is something we use. We talked about rocks. This week, we're going to be talking about water, specifically what we call natural sources of water. All right. So your target says I can identify and compare the properties of natural sources of fresh water and salt water. So water is a colorless, odorless, and tasteless liquid. That means colorless means it doesn't have a color, it's just clear. Odorless means it doesn't have an odor or a scent or a smell. And tasteless means it doesn't have a taste. And it's a liquid that makes up lakes, seas, rivers, and oceans. And it's the primary liquid found in living organisms. So, in other words, all living things have to have water to survive. Plants, animals, people, insects, worms, anything that is living must have water to survive. So, we have water inside of us. A natural source of water is a place where we find water naturally. Naturally means created by the earth, not man made. So, a swimming pool is man made. A swimming pool would not be considered a natural source of water. Can you think of any natural sources? So, I'll give you a second. If you'd like to pause the video, see which ones you can come up with, and then when you're ready, press play. And I'll show you, we're going to focus on 5 today. So here are the ones we're going to focus on: oceans, lakes, rivers, ponds, and streams. So right now we're going to talk about the properties of each of these and some important characteristics to know. So let's start out by talking about oceans. Oceans are very, very, very big. They are the largest body of water. They have what we call salt water. If you've ever been to the ocean, you know that it has salt in it because if it's ever accidentally gotten into your mouth, you can taste it. If it's accidentally gotten into your eyes or your nose, it kind of burns or stings because it has salt in it. Oceans make up 70% of the earth. So, in other words, most of the earth is covered in ocean water. This is why, when you look at a picture of the earth that has been taken from outer space, this is why the earth appears to be blue, because most of it is covered in ocean water. Oceans are always moving and flowing. They have what we call currents and waves, and oceans are home to lots of plants and animals. So, I want to go back to where I said they have salt water and that most of our earth is covered in water. So, you might be wondering, Miss Seals, if so much of our earth is covered in water, why are we always being told by our parents and our teachers and other grown-ups that we need to save water or don't waste the water? Doesn't that mean we have plenty of water? And you're kind of right. We do have plenty of water on the earth. However, most of the water is salt water, and salt water is not water that we can drink. It would make you very sick to drink a lot of salt water, not just to taste it, but to drink it. Um, we don't drink salt water. We don't use salt water to take a bath or a shower or brush our teeth or to give to our pets or our plants or anything like that. So, even though most of our earth does have water in it m- or on it, most of it is salt water, which is water that we cannot use. Okay. The next water source of water we're going to talk about are lakes. Here's a picture of a lake. Lakes are big, but not nearly as big as oceans. Lakes are a large body of water surrounded by land. Oh, I guess I kind of moved that picture there. Sorry. Let me go back to that. So we have a large body of water. See the body of water, and then it's surrounded by land. I see mountains, trees, rocks all around it. And most lakes have fresh water, but there are a few with salt water. There's one in Utah called the Great Salt Lake. There is one over on the other side of the world called the Dead Sea. It's called the Dead Sea, but it's actually just a lake. and it has so much salt in it that no plants or animals can survive in it. So that's why it's called the Dead Sea. But most lakes are freshwater. So by freshwater, what we mean is water that does not have salt. So this is water that we are able to use to drink, to take a bath, to brush our teeth, to wash our hands, to give to our pets. However, that does not mean that it is safe to drink the water straight from the lake. We definitely do not use the water straight from the lake. What happens is the water gets pumped out of the lake and goes through some pipes, and it travels to a place called a water treatment plant. And at the water treatment plant, the water gets cleaned and treated and made safe for us to use. So when you turn on the sink or the water fountain or you flush the toilet, that is water that has come from the lakes nearby, but it has been cleaned and treated and made safe for us to use. We are lucky here where we live because we have two lakes nearby. We have Lake Belton and we have Stillhouse Hollow Lake. So those two lakes are the where we get the majority of the water that we use here in our area. All right, so now we have rivers. Here's a picture of a river. Notice this S shape. That is a characteristic of a river, is that it has that S shape. It moves and flows with the land. Rivers are a large stream of water that runs into a lake or ocean. Rivers are always moving and flowing, and rivers have fresh water. So, rivers start usually up in the mountains. And what happens is, as the snow from the top of the mountains melts into water, that enters the lake, and that's called the source of the lake. Or, I'm sorry, the river. That's called the source. And it travels down, 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 and eventually it empties into a lake or an ocean, and that's called it's the mouth of the river. The mouth of the river is where the river ends and empties into a lake or an ocean. And rivers are also freshwater. We have lots of rivers here in Texas. Rivers are very fun. You can go fishing, boating, tubing, hiking, camping, lots of stuff to do at the rivers. Then we have a pond. Here's a picture of a pond. A pond is a small body of still water surrounded by land. Ponds are like lakes, but much smaller, and most ponds have fresh water. I'll come back to that in a second. So a pond is pretty much like a lake, but just much, much, much smaller. Sometimes ponds are small enough to be in people's backyards or on their property, but lakes are much too big. You wouldn't just have a lake in your backyard. And the water's still, it's not moving and flowing like a river. So when you think of lake and pond, think those things are very similar, just a lake is bigger and a pond is smaller. I said most ponds have fresh water. There are ponds that are near oceans, and they are actually a mix of freshwater and saltwater. We call those areas estuaries. So it's not exactly like a pond, but they're similar. And it's where the freshwater and the saltwater mix. And then we have streams. So a stream is a small, narrow river. The water's moving and flowing. So streams are just like rivers, but much smaller, and streams have fresh water. So let me go back to the picture of the river really quickly and point out to you, this river is very big. This is a picture that was taken from way up in the sky. Rivers are much wider and deeper than streams. You would not be able to just walk across most rivers. If it's a time of year where we haven't had a lot of rain and there's a drought, there may be points where you're able to, but usually it's much too wide and much too deep to be able to just walk across. However, a stream is much smaller. Notice this looks very similar to the river, but you could easily just walk across this. You wouldn't need to swim or get into a boat. So lakes and ponds are the same, except lakes are big and ponds are small. Rivers and streams are the same, except rivers are big and streams are small. The ocean has salt water. Most of all of the other sources of natural sources of water have freshwater. So this is an activity that for you at home would be very easy for you to participate in. Make sure you do have a grown-up's permission because you will be using, their cups and spoons and salt, and we don't want to waste any supplies. So make sure you have permission. But what you're going to do is you're going to take one clear cup and just put fresh water straight out of the sink in it. And then you will take another cup and put 2 scoops of salt in it and stir it up to dissolve the salt. And then what we're going to be doing is we're going to be comparing the look, smell, and taste of the fresh water to the salt water, and then trying to guess which one is the salt water based on what we see, smell, and taste. Then we're going to do an experiment, to see, got the hiccups. Then we're going to do an experiment to see how many spoonfuls of salt it will take for a golf ball to float. And I'll go more into that in a minute. So, all right. So I told you we are comparing fresh water to salt water. We're going to see if we can figure out which one is fresh, which one is salt based on the look, smell, and taste. So here, I'll go ahead and label these. Here, we're going to call this one water A. So I'll label this one A. And we'll call this one water B. So we're going to try and figure out which one of these is fresh water, which one is salt water based on the look, smell, taste. So let's start with A. And let's start with it how it looks. Remember that scientists don't use words like good, bad, yucky, yummy, excellent, great. Those are judgment words. You might think something looks good or tastes good, but somebody else might not think that. So we're going to use science words to, instead of just give our opinion, to describe what we're seeing or smelling or tasting, okay? So I'm looking at cup A, and I'm describing the look of cup A, and cup A is very, very clear or see-through. I can see through this cup of water very easily. So on my recording sheet, which looks like this, water A looks, I'm going to write the word clear. Okay. And then I'm looking at cup B, and it doesn't look the same as cup A. It looks, I would describe cup B as kind of cloudy or foggy. Would you agree with that? I can kind of see through it, but not nearly as easily as I can cup A. So on cup B, I'm going to write cloudy or foggy. Okay, so we have described the look of both of these cups. Now I'm going to smell them. And remember, when scientists smell, they do something called wafting. Instead of just, sticking my nose in there, I might not know what it is, so I have to be safe. So I'm going to get near it, and then I'm going to use my hand to push the smell towards my nose. This is wafting. And you know what? I can't really smell anything at all. So I'm going to put that it is odorless. Remember that word from the beginning? That means it doesn't have an odor or a smell. Water A is odorless. Let me smell water B. This is hard. Let me get a little bit closer. Water B it's pretty odorless too. I don't really smell anything. So I'll also put that it's odorless. All right, so now I'm ready to taste them. The kids in class will be getting a tiny little cup with a tiny bit of each of these. Since this is just me, I'm going to take a sip. All right, here is the water A. Okay. Remember, scientists don't use words like good or bad or yucky or yummy. I'm going to say, I could say that it's tasteless. It doesn't really have a taste, or I'm going to describe this water as having a very fresh and clean taste. This tastes like fresh, clean water. So I'm going to write fresh/clean. All right. I'm almost done with my investigation. I just need to write down the taste of water B. All right, here's water B. Ready? Whoa. Water B tastes very salty. I have a very strong taste of salt. Whew, so I'm going to write that it tastes salty. I'm not writing that tastes yucky or gross or disgusting, because some people might like the taste of that. But it definitely tastes salty. So here's my evidence for my investigation. For water A, we said it looks clear, it smells odorless, it didn't really have a smell, and it tastes very fresh or clean. Water B looks cloudy or foggy. It also was odorless, it didn't have a smell, and it tasted salty. So you probably already know by now that water B is the salt water. You're exactly right. Some of you may have already figured that out just from our first investigation with how it looks, because the salt definitely adds kind of like a cloud or a fog to it. And yeah, definitely has salt in it. So the salt water is water B. All right, we're going to do one more little investigation. And for this investigation, I am going to use my fresh water. This was cup A. It doesn't have any, excuse me, it doesn't have any salt in it. And I'm going to use a golf ball and a spoon. And in here I have some salt, so it's easy to scoop out. And I have paper towels. Okay, so I'm going to show you something cool. When I put this golf ball into this cup of water, the golf ball sinks to the bottom of the cup of water. So what this means is that the golf ball is more dense than the water. Density has to do with how much space something takes up and how much mass it has, or how heavy it is. Okay, so since the golf ball sank in the water, I know the golf ball is more dense than the water. But by adding salt to this water, I can eventually get the golf ball to float. When you add salt to the water, what it does is it increases the density of the water. In other words, it is increasing the amount of space and how heavy the water is. So eventually it's going to become more dense than the golf ball, and therefore the golf ball is going to float. So we're going to see how many spoons or scoops of salt it's going to take to get the golf ball to float. Here's my salt. Okay, so I want you to make a hypothesis before we start the investigation. Make a guess. How many scoops of salt will I need to add to this cup of fresh water before I can, or until I can get the golf ball to float? Make a guess. It doesn't matter if it's right or wrong, just a hypothesis, and then we will continue. All right, so I'm going to add a scoop. I'm going to stir to dissolve. I'm going to put the golf ball in each time and then take it out and repeat until we get our golf ball floating. So here is scoop number 1. I'm going to add it. I'm going to stir. I'm going to carefully add my golf ball in. Oh, golf ball sank to the bottom. It's not floating yet. So my golf ball is still more dense than my water. All right, so here is scoop number 2. Nope, not floating yet. Sink to the bottom. Golf ball is still more dense than the water. Here is scoop number 3. Still not floating. Still more dense than the water. Let's try 4. All right, here we go with 4 scoops of salt. Ooh, it's still sunk, but not as hard. So my guess is that maybe just 1 or 2 more scoops is going to get it. Here's scoop number 5. Oh, almost. It kind of hit the bottom and floated back up a little bit, but it is resting on the bottom. All right, here we go. I think this is going to be the one. Scoop number 6. Oh my goodness, still not. Ugh. Okay, what about scoop number 7? Cross your fingers. I really think this is going to be it. We seem really close. All right, here we go. Oh man, it's like barely skimming the bottom. Okay, this is it. I just know it. Scoop number 8. Cross your fingers. There we go. Can you see that? I'll hold it up so you can see. There's our golf ball. It is close to the bottom, but it is not resting on the bottom. It is floating. Wow. If I added even more salt, it would eventually it would cause the golf ball to float even higher, and you could eventually get the golf ball to sit on top. Let me try one more and see if we can get the golf ball to go a little bit higher. So it took 8 scoops of salt for our golf ball to float. Obviously, if you have a different container with more water, it's going to take more salt. If you use a smaller container with less water, it will take less salt. So here's my last scoop of salt. This is 9 scoops. So let us see what it does with 9 scoops. Whoa, look at that. Can you see? There's our golf ball floating about halfway. Whoa, there it is. It's pretty high up there. So with 9 scoops, if we added 10, oh, look at that. It's almost all the way at the top. If we added 10, it might be sitting on top. Wow. So we could say that it took 8 scoops to get it off the bottom, but 9 scoops to get it towards the top. Look at that. There we go. Our golf ball is floating. We have increased the density of the water by adding salt to it. All right, I hope that you guys enjoyed learning about water and comparing fresh water and salt water and seeing how we can make a golf ball float by increasing the density of the water. I will talk to you guys next time. Have a great day.